speakers tonight. We have Michael from Aqua, who will be speaking first. He's going to speak from now till about 8 o'clock, and then after him, we're going to put CoreOS on with Yoon Kim, right? Hopefully I got that right. Who will be speaking on blasting off with Kubernetes, running Rocket containers on your Kubernetes cluster. After him, we have Brendan, and we kind of shuffled the schedule to accommodate something for Brendan. So he's going to be going up last, and he's going to be talking on audit, insight, and authentication in Kubernetes and Google Container Engine. I also like to thank our sponsors, Apcera for food and drink. I'd also like to thank Google for space, and I'm with StackMy Cloud, and we're hosts. So at that, I'll hand it over to you.
Okay, hello guys. My name is Michael Chorny. I'm head of research of Aqua. We are just out of beta like a month ago. We're a container security company. If you want to hear more about us specifically, just come to talk to me after the talk. I have a lot of years of experience both in development and research, and we'll talk today about how we run our own security service on the G-Cloud. We have a service which is called Speaker, basically a scanner for known vulnerabilities. It also provides for container activities. Basically what it means, we run the images which user runs, which user want to scan. We highlight suspicious behavior, and it's totally free. The link is down there, you can go and try. This is how it looks like once you scan your image. You can evaluate the security posture of your image, see what is the known vulnerability, how many resources it takes, how it processes, both static and dynamic analysis of your image. Now, let's rephrase it again and reiterate on that. What we actually do is we not only statically scan your image, we automatically run actually an arbitrary image, which can be, the nature of any unknown thing that could be malicious. And each time we ask people or consulted people and organizations how and if we should do it, we always get the same result. Basically on all kinds of forms and all the same. But I guess we are either too smart or too stupid, I don't know. So what was our architectural requirements when we built it? We wanted, as any as any service which goes to web, we want it to be scalable on front end. Our scanners, which perform the static scanning and spawn the malicious images, or not so malicious, to be scalable as well. We want it to be asynchronous, and we obviously want the whole thing to be secure. So people who want to play won't play too much on our account. So what was our security concerns? Because after all, I'm here to talk about security. We want our web front end to be secure, so we run all kinds of tests around that. And we want the malicious, the containers, to be safe around games there. So what container could do potentially? It could be exploding, in a sense, using too much resources and killing our machine or the host it runs on. It can try to do lateral movement to the neighbor containers which our users run or try to gain persistence. Or it can even use us as a foothold to attack the internet from us. Use us that we actually really don't want that. So let's see. From the local perspective, there's things like forbomb. I guess you know this forbomb, right? So we will describe and demo it a little bit in 2 slides. Fallocate is basically a function or a call which allows to allocate a big amount of space on a disk without even doing anything about it. Or resource consumption. Basically, it's all 3 types of how you would overconsume resources on your computer. or on the host which container runs on. And another vector of concern is a network. East-west, what we talked earlier about the lateral movement between containers, and the northeast basically out to attack either ourselves or the broad internet using our infrastructure. So how we chose to implement that for scaling and some of the security issues we use in Kubernetes on the cloud, and we add our own secret sauce, so basically use our own product inside of the whole thing. This is the very broad diagram of the infrastructure, of the architecture. We have a web pod with servers from front end, which pass the requests to the queue. Now for the containers, which are going to be running, the scanning happens in a different cluster, a backend cluster. We have here separation, which pulls from the queue the requests, perform the scan, perform the execution of the containers. They have a service from the front-end cluster to perform MCV scanning. And this is how it looks like. On the backend standard, where we run the containers, we have our own product actually running to protect ourselves. From the security perspective, we had a standard best practice measures like log everything which happens. We use kubectl to contain container, to access containers, to minimize the need to use SSH. We apply default resource quota and limits with Kubernetes namespaces. And to limit the amount of the network access that containers might have, we separate ourselves with Kubernetes clusters. So how do you protect against those malicious containers if somebody wants to do something bad? From a local perspective, we run those containers obviously as unprivileged. It's never run as with privileged. We use user namespaces to prevent containers to eat too much data, too much disk space, and basically kill the machine through the host through that vector. We put the data for containers on separate partitions, and we have, just like I said, ourselves installed there. From the network's perspective, containers actually run without any network access. They closed by firewall and by IP tables rules. And the backend cluster has no internet access, only to the front end cluster. And the communication between the clusters is actually limited to very specific connection points, hook points, and the separation itself. Questions so far? Yes, please.
Do you encrypt that data between?
Yes. So now we will take one of the more dangerous attacks in Bitcoin talk, the fork bomb. First of all, we explain it. Basically, fork bomb, the idea behind that is to make the host run out of available PIDs, process IDs. Every time you fork a new process, it needs a new PID. Once you run out of this, you cannot create more process, your system is dead. The first line here above is a piece of bash code, okay, which basically what it does, it defines a function, and then it executes itself with a pipe. Pipe itself generates a program, forks to function recursively by itself, and this works recursively. So basically, you have, just like this drawing, we have an endless binary tree of processes which do nothing, and the system freezes immediately. We'll see this in a few minutes. I will kill myself. Oh, great. Now, how actually the fork bomb? Any questions about what is fork bomb? One. So how actually you can protect against fork? There are certain tools which Linux itself provides. One of those is ulimit utility, which basically allows to define the limit on certain quote on certain things. The number of processes which can be created is one of them. But it's only works per user per session. Basically, if you create 2 logon sessions, each one will have different limits. Now, in context of Docker and containers, you can either run container with ulimit, or you can define it on the daemon level. So if you define it on daemon level, because most of the containers in many cases run with the same user, they will share this thing. So it's not very usable. And another big problem is that many containers today run still running with a root user, and the ulimit does not enforce on root, so it doesn't help. Whereas in new kid in town, PID C group, you know the C groups? C group is a control group. This is one of the main methods for encapsulation and sandboxing of the containers. And but it's a new thing. It will be only in kernel 4.6, which is not yet here for most of us. So it can not be used either.
Gotcha. CoreOS has got yet.
Cool. So now let's kill ourselves and see how Forkmap actually looks like and feels like. So just copy paste. We can actually paste from here. Whatever. 1 second.
It's going to be in Windows for Bash. Sorry, Bash for Windows.
No, why? No, it's going to be Bash for Linux. So I thought about that one, but decided to go things today. Okay, so we are good. So first of all, let's see. I'm going to run my own container.
Could you increase the size of the?
Yeah, we'll try to. No. Okay. Yes, I didn't do that. 1 second, sorry. Like this. Yeah. Let's see if one is good enough. Good enough? Yeah. Let's continue, I think. Okay. Big enough? Cool. So now I'm going to run Docker run my own container. It's basically nothing special, just send us with a number of tools I include there, no magic. Just I need to write comment. Okay, now we have container there. So now I'm root. I'm not going to run Forkmap get at root to see that I'm dead. I first will do sudo minus Alice, I think? Yes, no. Add user Alice, su minus Alice. So I'm Alice, okay? Now if we'll see, we can see that the U limit on the max user processes is 4K, okay? So I can generally create 4K process, it's too much. I can now do U limit minus U10, okay? And now if I will try to execute a fork, this is the line down there, it's basically will limit me. It says no child process because it's trying to do the recursion and basically fails. But what really important is that the real user of my container, which is root, if I'll do it now here, okay, I'm dead. I promised to kill myself, right? So now I'll do just the same on the host where we have Aqua installed, because this is where we had to use our own secret sauce. Okay, so I'm running the same container and pray for the best.
Run.
You're right. Not here. Tools. Yes, thank you, guys. Because I'm a little bit notes. Okay, and now I'll run the fork and it just doesn't work for root. This is not important here, okay? The system is alive, we are protected, for roots too. Cool. Let's move on. Questions? Yes, please.
Can you have multiple sessions and then do that same command across multiple sessions?
Sorry?
Can you have multiple sessions and run that command across the multiple sessions?
You can, inside that one container, you will not be able to have more than the defined limit of process. So you can have, but it's not, it kills the possibility for the attack. That's right. Huh?
How does it work?
Secret sauce. Come to be our customer. We basically count the number of processes which run within the container. We just do it in real time because one of the questions people ask sometimes, and you could count, you could done cut proc PID procs to see how much process you have in for your PID. But this wouldn't work because it's too slow. The moment you do cut, you're always dead. Something like that. You cannot do those. You cannot protect against fork bomb with those kind of things. You need to be where it happens. This is why the PID groups, which was developed in kernel, and they happen when the fork happens, not like monitoring the neuron. Okay, in parallel. Questions?
You can do C groups by setting the driver for LXC.
Sorry?
You can do C groups by setting the driver for LXC. Even if you're not using it at the time. You can prevent this at the C group level in many cases at this point.
You need, if you don't have PIDC groups, which is not in most kernels, you can't.
It's not?
No, because this is a new type of, new class of new type of CSC group, which is been pushed to mainstream, and I think it's kernel 4.6 and Koros. But with C groups as they are right now, which is just no type of C group you can protect against that. So we saw a fork bomb demo. Now this is our shirt. Now when we know what this sentence means, it's funny actually. And if you want shorts, we got set shorts here. Just come and claim them. After all, we have to document, right?
We only have 2x.
No, we also have Excel. Excel and 2XL. We also have pens. Okay, questions?
One other quick question.
Yeah.
I think you mentioned user namespaces
Yeah.
before. If you're in a user namespace, you're running as non-root.
No, you run as non-root on the host. You still root
And
in
then
the
any ID limits for users on the host won't apply to you. So if you had a user ID map that already had that limit, that wouldn't apply.
No, because
That's true.
it's cool. This is my questions. Thank you very much.
So we're gonna have Brandon demo some new stuff from CoreOS.
Oh, it's not from us.
What?
Like we didn't build it. We're just participating. It's an upstream project. Who's heard of Minikube? It's a new project for Kubernetes. Okay, cool. I'll just give a quick demo. So how many people are running Kubernetes on their laptop, like in virtual machines or something? Very few people. Minikube makes this easier. Oh gosh. Cool. Okay, so Minikube is a new project. It's at github.com/Kubernetes/Minikube. There's a number of people working on it right now. I've put in a couple patches so far, and the patch that I added was VMware Fusion. So VMware, where is it? Somewhere in my patch history. No. All right, well, in any case, what you do is you download Minikube or you compile it. And Minikube is a single command line tool. And what you do is after you get it, you type Minikube start. And then in my case, I type VMware driver equals VMware Fusion. But by default, it'll use VirtualBox. And the goal here is to release this in the V1.3 timeframe, so in the next couple of weeks. And over time, we'll start to add things like Xhive or like native Hyper-V integration on Windows and that sort of stuff. So after typing Minikube start, what happens is that you will automatically configure your boot config or your kube config. So it'll modify this file. And so immediately after typing start, it will dump out the IP address and port of your Kubernetes cluster running on your laptop. You'll be able to do things like git pause. And that all works. And then it has a cute number of different command line options. So I can do like eval Minikube Docker-imp, and that will make it so it exports all the required Docker environment variables. So I can do things like Docker.ts on host and that sort of stuff. And I can also do cute things like do Minikube dashboard, which will automatically open my browser. I'm not going to type this because my email is open, and it's just going to flash my personal email for a second. So I'm going to pass on that demo. And so, yeah, that's the overall thing. It's a new project. We'd love to have more people involved. Obviously, like to have more people trying it out and using it as well. So go check it out on the GitHub repo. Thanks.
What was your name?
Oh, sorry. I'm Brandon Phillips. I'm the CTO of CoreOS.
Let's see if we can figure out how to get this working. Can you see it? Yeah.
Like you said, it was the years of the desktop.
Not the Linux laptop though. Desktops are actually easier because they don't have to deal with monitors that change. Where's the X render command to just copy the screen? Where are you? Sorry about the trouble. Oh, that's really the broken cable. That's what I'm saying. So I see that.
Bingo.
Oh, awesome. Okay, and to the presentation, which hopefully works. Okay, awesome. I'm going to be talking about Kubernetes. First of all, I'm Ewan Kemp. I'm a developer at CoreOS, and I primarily work on the Kubernetes project. If anyone wants to ask questions at any time, feel free to just make some motions, raise your hand, whatever. I'd be happy to answer any questions throughout. So first of all, you might guess based on the name that Kubernetes is related to Kubernetes and related to Rocket, but not everyone knows what Rocket is perhaps, so I'm going to quickly give a little bit of information about that and why that is an awesome part of it, just like Kubernetes is an awesome part of it. So Rocket is a container runtime, just like Docker and various other pieces of software out there. It allows you to run Linux containers on Linux machines. It does all the fancy namespacing and all that wonderful stuff. The main reasons it was developed was to be secure, composable, and standards-based. It came out in about mid-2014, and it hit 1.0 very early this year, but it's had a very long road, and it was stable, I would say, before 1.0. So it's a great project. And as I said, it's standards-based, and when it was first created, it was created along with the app container standard, which is a specification that tells you how you can run a pod, a group of containers. It tells you how you can set up networking and so on. It tells you how an executor can actually execute those things. At the time, it was pretty much the first well-defined standard for running containers. It was based in part on Kubernetes concepts. You might recognize the name pod there. And Rocket also is happy to use new standards. As you can see there, it's planning to be OCI compatible once that's actually possible, waiting for 1.0. Container Network Interface is a project that spun off in part to help it, in part to help Kubernetes, and it's been happy to use it as well. It was built to be secure, so it's secure by default. It requires all images to be signed, and you can turn it off if you want to, but you by default have that security. It has TPM attestation that can tell you, I've only run these images that I wanted to run. You can go back and look at a tamper-proof audit log and make sure this image ran, this image didn't. And we at CoreOS, of course, think that's very important to be able to know what software is running and hasn't. It has a good bit of privilege separation, so you can do things like download images without ever having root. Right now, you can only run images with root, but there are plans to make that a better story with user namespacing, so you can do everything without root, but there is no central daemon that requires root, and there is no reason to need root for many of its operations. And of course, it has SE Linux, and SE comp support is work in progress and so on. So it's also, and to me as a developer, like the most exciting thing about a piece of software is when it's easy to use and when I can extend it really well. And Rocket has great features for making it composable and extendable. And when I say composable, I mean it works with the tools I already have. It's very easy to integrate with other tools. And when I use it, it works mostly how I expect. It plays nice with my workflow. And it follows the Unix philosophy mostly, so that's a great way to help it do that. It integrates with systemd, which is not totally ubiquitous, but it's getting there, and it's wonderful to have things that just work with it. And it also, kind of in line with being built with the Unix philosophy in mind, it really works well with orchestration systems that want something that's mostly simple, that just is easy to integrate with. So it does that very well, and it also has a lot of features to make it extensible, including network plugins, configurable for image auth, and it has a state-based architecture. I'm going to talk about these bits in a little bit more detail. So one example of its composability is if you run Rocket, you run a container in some C group that already exists. In this example, you created a C group with block IO weight, then you'll find out it happily will run as a child of that C group. It'll keep a very sane hierarchy, and that limit will apply to it, even if you didn't specify it on that. And that's true of a lot of other ways that you can run it, where it will just stay as a child and do the right thing. It integrates well with almost all of its systems because of that, right? It also integrates with machine CTL, so you can get little niceties like machine CTL stop will let you stop it, and so on. It's extensible with a staged architecture, and this is one of, in my opinion, the coolest things about it. So you have like the idea of a spaceship where the earliest stages are very powerful, and over time you end up with the small final stage, which is what's actually most important, you know, where the astronauts are, your payload or whatever, and the previous stages just boost you towards that final stage. So what that means in Rocket is the lower stages generally run higher up in terms of the privilege chain. The stage 0 stuff is all just the static Rocket binary running on your host. It does things like download images. It does things like kick off the execution of the other stages via Rocket Run, lets you list containers and so on. The stage 1 itself is, you can perhaps see the dotted line. That means it is something that you can swap out. It's extensible in that bit can be changed and configured. And I'll show you an example of that in a second. But the things shown there are the default stage 1, which is going to use systemd nspawn to set up all your namespace isolation, all that wonderful stuff. It's going to use CNI to set up some networking for you, and it's going to do any bind downs you have, and so on. And then the stage 2 is your actual application, whatever the user wanted to run. If they type rocket run mywebsite.com/Redis, then stage 2 is going to be that Redis bit. So a quick demo of what these stages look like. You can see that, so we're going to be using this so that I don't type any commands. It's actually running the command. This is all legit, not a fake demo. So you can see I don't have anything running, and that's nice and simple. We can then use systemd run, as I was talking about earlier, to create Rocket as a daemonized process in a same C group hierarchy. It will create its own C group hierarchy if you just run it by itself, but it's often a good idea to run it as part of a systemd unit if you can. And we're just going to run the Alpine Linux container, which is going to print something every second. And this bit's kind of boring. That's anyone can run that, right? You can run that with whatever container execution engine you want. But it's nice to see that it integrates beautifully with systemd. So like we check the status, and you can see it's printing stuff there. Journald would let you filter down to the actual application doing it as well. One thing to note here is the actual process list that you end up with. You end up with the slice that was created for that transient unit that we made. You end up with what was a stage 1 process in the stage 1 Rocket setup, and you end up with systemd as part of the stage 1, which is going to then run your applications and manage their life cycles, including doing the reaping of any PIDs when they exit. So you can't easily end up with the zombie process that you sometimes end up with in Docker. You have to really go out of your way to make a zombie because you have systemd right there at the root in the namespace that will be able to handle that. And we also have journald for logging in here so that we can integrate well with the host journald. We have that run to the guest. But the really cool thing, I was talking about how you can extend with just your stage 1 is swappable. You can put an arbitrary stage 1. So if we instead run this right here, if you look at that, you can see it's the exact same command with one difference. It has a stage 1 name, and it says stage 1 name CoreOS Rocket, stage 1 KVM. And that's the only thing that changed. We're still using the exact same Alpine Linux container. And if I run that, then it's going to launch another unit. And if you look at it, you can see that the process list is a little different. You see there's LKVM, which is a lightweight alternative to QEMU pretty much, that started up a virtual machine. And you can see it's still integrated with journal CTL. We still have the logs from it. You can still do Rocket enter and run commands in there. It's a well-integrated experience, and it's because there was this little toggle where I can swap to stage 1, and the stage 1 has a contract to then start the application, just like every other stage 1 would do. And you can see it ends up running there. You can see that machine CTL shows one of them. And anyways, that's a demo that I wanted to show about how cool it is that you can extend Rocket with stage 1. So hopefully, switch back. Click that, right? Click. Okay. So hopefully that makes sense about why Rocket is so awesome. Now I'm going to very briefly touch on Kubernetes. I'm sure you're all already familiar with it. but I wanted to touch on one particular concept in Kubernetes that is oft repeated. It's a very flexible and extensible system. If you look at it, pretty much every bit of it is something that can be configured or that the user can supply their own implementation. The scheduler, it was designed in a way that you're supposed to be able to put in your own if you wanted. The load balancers, it integrates well with arbitrary load balancers on pretty much every cloud provider and your own HA proxy bank or whatever the heck you have. And it can run just about any container. It explicitly isn't trying to be a runtime for only certain types of things. Like Heroku was really good for Rails apps when it launched. Kubernetes wants to be able to run absolutely anything. But if you go on and then you look at the reality of what Kubernetes was, it turned out that it could only run any Docker container. And that isn't exactly the same thing. And we've just heard about how awesome Rocket is, right? There's more than just Docker out there. So how Kubernetes actually runs Docker containers or ran Docker containers then was pretty simple. There's a kubelet on every node. It just talks to the Docker daemon and schedules pods. And the actual way that's implemented is a single interface. And it basically looks like that. If you look at later Dockers, it looks slightly different. Some problems with the model, especially in previous versions of Docker there, was that Docker didn't natively understand pods, so there was lots of translation. The Docker daemon is this giant single point of failure that if it goes down, everything goes down. That's a little unfortunate at times. And there's also not really much systemd integration. The cgroup hierarchy is a little wonky as a result with many Docker configurations. With newer Docker versions, it's quite a bit better. It's taken some lessons from Rocket perhaps in its process model, and that your processes are, like the containers the user runs are completely independent of the daemon as of 1.12. And it's just, the daemon spins off processes running separately. There still is a daemon, it still takes resources and then does state management, but it's a lot better, and that's awesome. But regardless, there are still reasons that it would be nice to not have to use Docker. It still has overhead for containers. It still is a large piece of software that does a lot more than just Kubernetes use case, which is great. But with Kubernetes, you might also want something that does exactly Kubernetes use case. And it also still doesn't really fully integrate with systemd. But anyway, so if you look at what we just talked about, we talked about Kubernetes has this Docker container runtime. But if you actually think about what it needs to do, that's pretty much the list. It needs to be able to create pods. It needs to be able to do resource isolation for them. It maybe needs to do networking, though Kubernetes can sort of do that for you. It maybe needs to do volume mounts, though Kubernetes does most of that. And it doesn't anywhere say this needs to be Docker. Like if you read the API, it doesn't say run a container, this container must be Docker. If it's not Docker, then it's not going to work. The API was very well abstracted. And if you look at the previous slides, you can see that the kubelet had these ideas of pods that were meant to abstract it. It's very clear that you should be able to put something in there. And so now we've got to the actual subject, Rocketetes. That is what Rocketetes is. It's the idea that Kubernetes can be run with multiple container runtimes, and since Rocket is an awesome container runtime, we want to make that happen. So Rocket is the first integration of an additional runtime into Kubernetes. With that, the kubelet calls to Rocket for pretty much all the stuff you would expect a container runtime to deal with: image discovery, fetching, and then actual execution of it. So how does it work in the Rocketetes case? It's actually not that different. Like before you have kubelet talking to Docker, now you have kubelet talking to Rocket. Before you had kubelet talking to Docker to do everything, now you have kubelet talking to a Rocket API server and Rocket and systemd to do everything. And there's a few more steps there, but we do think it's worth it. You end up with a diagram like this, and there's one thing there that is very critical single point of failure. You can see it's systemd. In fact, if systemd goes down, all your containers go down. Fortunately, your entire system went down too, so you don't really care. It's kind of, at that point, who cares? And the API service, which looks like it might be a point of failure, the reality is it's a read-only API service, and when it restarts, it doesn't cause any impact to your running containers. You just won't be able to, say, get the logs of existing ones until it restarts. So that bit is kind of there as an abstraction layer. And we'll talk about a little closer to the end what that might become in the future. So the actual benefit is you don't have a daemon that is required for state management. This read-only daemon is basically stateless, and it doesn't provide the same level of perhaps burden as the Docker daemon. There's also some cool flexibility you can get with multiple stage ones, which, I mean, I showed you how awesome it is that you can run just the exact same containers with 400 KVM. Well, the Intel guys took that and they've already managed to get Kubernetes launching containers as VMs everywhere, just entirely VM based. And there's a few caveats with that, but it's really powerful. And I know that Kubernetes is working to have even more first-class integration there. So it's a cool way to get that going. And there's also still the integration with systemd. That all still works when you're running it under Kubel, when you're running it besides, it just works. So there's a few other benefits as well. For example, it paves the way for these other runtimes. I mentioned how some people at Intel got this Kubernetes project working to launch entirely VMs. There's also a hyper project, which is to get Kubernetes to launch VMs. And they have their own way to do it. And I talked to them at DockerCon and it looks really awesome, but it's a bit of work that's only really possible because Kubernetes is here to make it easier for other runtimes. And there's also a proposal for runc. And I've got a little performance graph that's hard to see, but already we've found some benefits with a carefully picked example of Rocket versus Docker performance. You can end up with Rocket launching more pods per minute than Docker, which is it's cool. We still have work to do on optimizing every case, but there's already some cases where it's noticeably improved. So what's the actual status of this? Because like I talked about how it was all Docker, there were Docker assumptions. Well, we're at 1.0 pretty much with the Kubernetes 1.3 release, which was supposed to be today. No, next week, right? No, it got bumped forward a little. So the little party hats there are a little premature, but when Kubernetes 1.3 releases, you'll be able to just set a container runtime flag to say Rocket, make sure that you have Rocket available and the API server running, and all your containers will run as under Rocket instead of Docker. There's a couple details about what Kubernetes 1.0 actually means here. And what it really means is that it's basically a thing that you can swap in place of your existing Docker setup. It's not actually running Rocket ACI images. It's still running Docker images because Rocket can run both Docker and Rocket images, and Kubernetes doesn't yet have a way to specify different image types. It's not using a KVM stage by default or anything. It's just using a nice and normal systemd stage one. Everything, though, is supposed to just work as it worked before, with only a few exceptions. And you can see there's, with a small set of known issues, we have pull requests to the documentation to list them clearly so that you can know these are the things that are known. Most of them won't impact the majority of applications, and we are going to work hard to make sure that we get complete parity there, as well as adding new features. So Kubernetes 1.3, when that happens, it'll be right there for you to play with. So I'm going to give a quick demo of what using Kubernetes actually looks like. And so if I switch to my Kubernetes folder and source my demo env, then we can see that if I just get the nodes that I have, I'm sure that works too. We have some Kubernetes nodes, and if we get my current pods, I went ahead and started the Tectonic console so that we can look at it in Tectonic. If I just, there we go, Tectonic. And if you don't know what Tectonic is, that's a product that CoreOS offers that allows you to have a nice GUI for your Kubernetes cluster. If you get just the free starter edition, which I did, this is the free one. You guys can use it for free too. You get some other awesome features if you pay money. But anyway, so if we go and we look at the nodes, excuse the resolution, you can see, for example, that when you look at the container version, it just says Rocket. Ooh, that's awesome. If I go and run a pod, then let's see if I can manage to actually create one with this resolution.
Control minus minus.
So if we just pick a regular Docker image from Docker Hub, it'll run pretty much like you expect. Let's go back and do the sleep, the while true date thing, because that's an easy way to see that something's actually happening. And did I? Oh, thank you. Yeah. Yep. Thank you. You guys are an awesome audience. And if we watch that, you'll see that container running. That was nice and quick. If you look, things like the log view, which is harder to find with this resolution than it was You know what, we're switching back to the CLI for this. So if we look at the logs, then you can see kubectl logs just work, saying, no surprise there. Kubectl exec, sure, let's do that too. Okay, right there. So we do have a slightly different process tree, but still in a nice little container there. As I was saying a bit ago, part of this was also to just make most applications just work. I don't know if you guys are familiar with the infamous guestbook example, but totally unmodified guestbook, which is a commonly used example of things. And if we, so we go back to the Tectonic console and look at the services that created, we'll be able to see that, hey, looks like that might be good to go. Nope, no load balancer yet. It's trying to connect to a load balancer. That always takes a little bit of time, but with no changes whatsoever, if we with no changes at all, it just ran all those containers just fine. And if I SSH in, you would see that the Docker daemon isn't running at all. And eventually we'll have a load balancer that we can connect to if we want to actually play with the application. But I assure you, well, there it is. I assure you it does work unless my demo broke. Yep. No Docker involved at all. Just lots of wonderful Kubernetes and wonderful Rocket stuff. So the last thing I want to do after showing you all this awesome stuff is give you a little bit of a sneak peek towards what we're going to work towards next. I found out, by the way, that you can have GIFs in Google presentations. I never knew that before this. This is the future right here.
Damn you, Google.
There's Rocketettes and then there's GIFs.
Link tags. Yeah.
Anyways, so one thing that's happening in the near future is a rework of the interface, which is also going to help allow those other runtimes to integrate better. Right now, we're integrated in process, as I showed earlier, and this interface is going to make a uniform way to integrate that doesn't require quite as much work for people. It's also going to move pod level things to container level. How that's actually going to work in Rocket is kind of interesting, since Rocket is primarily a pod runtime, right? But how it actually can work is pretty easy. Systemd lets you do very granular things with a systemd and created namespace that is integrated correctly. You can just use the systemd dbus to communicate commands to it, and you'll still have this pretty pod abstraction, this systemd that is running that will read your process directly, that holds all the namespaces open, and then you'll be able to interact with it to create new things. So what it'll actually look like is you'll, instead of having this, you will have this systemd and a systemd on the host, register, control, where these are systemd dbus calls to create a new application, restart one, whatever. And that will also fix a couple of the caveats we have. For example, single containers don't restart, whole pods restart under Kubernetes. We also are really hopeful that we'll be able to get image type support so that you can run OCI images, Docker images, and ACI images. And Rocket will, of course, support all of those. This is a really old issue, as you can see by the fact it's only 4 digits. But it's one that we're really hopeful we'll be able to get good traction on now that we've got Rocket integrated. We also, there's been a lot of discussion about switching to a client-server architecture, and this kind of fits in with container runtime interface I talked about a second ago, where you end up with, instead of the API service that we had that is read-write, a specialized adapter from the kubelet to your actual Rocket containers. And if any of you are interested in that, you're welcome to join that discussion as well. But if you're interested in any of the stuff you've heard, if you think Rocket's awesome or Kubernetes is awesome, all of the stuff I talked about, except the Tectonic console, is open source, and we would love for you to join in. We have a SIG. If you guys are familiar with the Kubernetes special interest groups, which means we have a Slack channel and email list. We have weekly meetings. You guys are all welcome to join. Hope that you guys will also use it, because I mean, even if you don't join it, it's still cool software, and we'll be happy to take bug reports. We'll be happy to fix them for you. Thanks, everyone. Again, you guys are awesome. Anyone have questions?
Does Forest offer something like a universal control plane like Podcast?
Universal control plane?
Some dashboard management for process?
Sure, you can pay for Tectonic and get the premium product. And I'm not the best person to talk to about that though, because I mostly try and work on open source, and our sales guy will be happy to tell you more of the wonderful things there.
I was just asking if you could repeat the question.
Oh, sorry, his question was, does CoreOS offer something like Docker Universal Control Plane, an enterprise product for managing your containers and so on? And I was saying, yes, Tectonic has a premium enterprise supported version that we'd be happy to offer. Anyone else? Maybe I was too quick. Don't see Brendan Burns around. Oh, there he is.
I discovered the last conference I talked at that this Chromebook doesn't always pick up HDMI without a reboot, so I'm gonna have to reboot.
New messages. Not me. 4 people came with me. Good. No.
Brian's got PCX right here.
A lot of messages. Oh. It's probably just misrepresenting something.
Oh yeah, it said it was extending to it, so it sees it, but I just don't know if that's the right. Or if I did. Should have brought my Clark laptop. Yeah. Could be exciting. I should know how to do this, given that, you know. Is this the one that he was on? He was on that one. That's my goodness. Oh, is that? It's the VGA.
Yeah, you were on though.
Oh, you were
on. There you go.
No, is that right?
Those look like Chromecasts.
Yeah, that's on me. That's fine. I could just borrow the. Yeah, I could just write machine. Just give me an incognito window and I will be happy. Although my demo will not work, which is kind of too bad. You need Chrome? Yeah, but I don't care. I need docs. Plug it in, it's probably still extra. You gotta use. Yeah, right, use this one. Yeah, that's fine. That's really, yeah, that's.
Definitely try to browse that.
That's fine.
Let's put and see what happens again.
Actually, maybe I'll just think I could just email you a PDF. That's probably even easier.
Security, very hard.
Yeah, because I realized actually I have this. It's in the machine. Sorry, what's your email? AM. And not a. Yeah, you hate that. Looks like. Okay, there we go. Yes. Ah, cool. Thanks. Let's unplug for a second. Oh yeah. Hey, do you know how to switch it to HDMI? No, it didn't. It didn't. When it picked up the display because it said it was intending to the display.
Did anybody lose a driver's license by the name of Aaron Michael Harkenberger?
Do you have this meeting? Because if you just invite me, I can hang out screen share.
Okay. You know
Right,
Michael.
but I'm not on my Google account, my personal account.
Aaron Michael.
I guess that's right. You can. You should invite me to that. We'll have to show you.
Oh, yeah.
No,
You can see you now.
yeah, that's the one. No, I sent it. Look at the PDF.
Yeah.
It's really weird. I opened it up. Just all white pages.
Yeah.
I'm sorry. All right. And I should have brought my corp laptop. I knew I should have brought my corp laptop. How do I get all fancy?
Get something.
Oh, wait.
There's a screen share going behind you. And presentation.
All right, there we go. Yeah, magic. The demo's not going to work sadly because it's on the laptop, but not here. But
You can hold it up.
I'll just like relay it. I'll just speak it back. But I can we can go through that. Appreciate everybody sticking around while I had technical difficulties. That will teach me to never use a Chromebook again. I shouldn't think like that. I actually really like my Chromebook. But, anyway. So I wanted to talk today. Was anybody at GlueCon? Good.
Yeah, I was.
You were you there? Did you see my talk?
I did.
All right. Well, it's going to be boring for you. I apologize for that. This is the same talk that I gave at GlueCon. But I want to talk a little bit about introspection, audit, and insight via cluster management. And I'm going to talk about Kubernetes in specific, but actually I don't really think that this is specific to Kubernetes. I think this is a piece of functionality that is present no matter what kind of cluster orchestration you start using. It's just something that happens when you start thinking about things in terms of applications instead of machines. All right, so why do we want to do this? I have to figure out how to do it. I wonder if there's a way to go paging. So the reason, I think there are really three different aspects to this. The first one is introspection. And the reason that we're interested in introspection is we all carry pager, or at least many of us carry pager or have carried pager at different times in our lives. And when that pager goes off at 3 a.m., what you want to do is be able to figure out what's going on as fast as you can. What does the world look like? What are the problems that are happening? Why is the problem happening? I need to be able to dive through and do introspection. This has to be dynamic because, every single problem is different, every single cause of a problem is different. So we can't just sort of have this, fixed set of queries that we execute or a fixed set of statistics that we do. We need to be able to do this dynamically. As we learn new things, we're going to refine how we explore. It needs to be a dynamic kind of system. All right. Additionally, we want to do audit, right? We have people who push to prod. They don't even check their code in. Right? This is very bad. And this isn't just bad because somebody maliciously can push code out that sends all of your user data off to China. But it's also because this guy could push code out to prod and go on vacation for 2 weeks, and suddenly the state of prod is locked on that person's laptop and is inaccessible to anyone else. Right? So you don't even understand what's going on because you can't even see the code that's actually out there running because it's never actually existed in a shared resource. It also means that all of the stuff you're doing around unit testing and version control and everything in code review and all of the stuff that you kind of bind in with the notion that code should be checked in stops happening if it's possible to push code to prod that wasn't checked in. So that's audit. And then finally, there's insight, right? And I discovered that you could do animated GIFs in PowerPoint too, but once you export them to PDF, they stop being animated. So what can I do? And then that's the third aspect where it's not, the pager hasn't really gone off. And you don't need to validate anything, but you actually want to explore your system. You want to understand and gain new insight into things about the way that the world is operating. For example, what is the program that crashes most often? Right? What is the team that is responsible for code that crashes most often? You can do things like this with cluster management, and we'll talk about how and why, that you simply couldn't have done before. And that's sort of, I think these three categories are the interesting things that you can sort of, from an information perspective, the things that you can obtain from a cluster manager. All right, so what are the requirements for introspection? You need to have a specification. What should be happening? What do I want the world to look like? If the only thing you have is, well, people SSH'd into this machine and they ran a bunch of shell scripts, you have no idea. Introspection doesn't do you really any good because you don't know what the world is supposed to look like. So how do you know if the world actually matches what the world is supposed to look like? You need status. What is happening? What's going on right now? Events, when did it happen? More often than not, you want to be able to say like, well, the status is that this thing is crashing all the time. But I'm very interested to know that the event is that somebody pushed code at 10 p.m. right before they went to bed. Right? So there's this difference between what's happening now and then when did things happen. And then finally, attribution, which is who's the person who pushed that code at 10 p.m. and went to bed so that I can call them up and tell them to fix the problem. Right? So these are sort of the requirements for introspection. For audit, we need to have transparency because we need to be able to see everything. We can't really, there's not a great deal of transparency in people SSHing into a machine and changing things. I mean, you can log commands and things like that, but it is very hard. And even then it can be tricky, right? Because I can say something like cat, foo to whatever, and I may have logged that command, but I probably didn't actually log whatever you typed in when you took it in on standard in. We need immutability because if I'm going to go in and I'm going to see things, I need to trust what I'm seeing, right? I need to trust that when I see it, it means that it will be that way. It has been that way, and it will be that way into the future, right? The example I like to give here is, anybody out there own a Volkswagen TDI, right? So, you need, it's not, if you test it and it does one thing, and when you actually drive it, it does something else, the test doesn't really mean anything, right? So we need immutability. We need verification. We need the ability to say, like, actually, the thing that you're reporting to me is actually what's going on. So this is kind of the difference between black box testing and white box testing. You need to be able to actually get in there and verify. We need to be able to place restrictions on you because it's great to be able to audit and be able to go in and say, like, hey, you're doing something bad there, and I'm going to turn down that container because you didn't do the right thing. You pushed code that wasn't checked in, or you violated some other restriction, but it's a really bad user experience. It's a really bad user experience if I push something in and I think it worked and I leave and some automated system comes through 3 minutes later and says, no, that's not good, and I'm going to delete it. I may not notice, right, until I get paged because my application is no longer running. I need to have restrictions and limits, both from a user experience perspective, and also because honestly, when it ran for those 2 minutes, it could actually do some damage as well. And then finally, we need automation, right? We need APIs because honestly, I don't want to do this stuff myself, right? I want to set something up that does this kind of auditing, run it for forever, and just look at a dashboard every once in a while to make sure that everything is still green, right? So I don't want to be auditing and doing manual audits. I think oftentimes when I talk to people who are doing these kinds of compliance and this kinds of auditing, it's very, very manual, and that's horrible. Both from a human existence perspective, because I feel bad for those people, and also from a reliability perspective, because it's very hard to make sure you're doing the same thing every single time. All right, so what are the requirements for Insight? Well, we need to have dynamic organization. As I was saying before, there's lots of different perspectives, there's lots of different questions. We also need to have some degree of visualization. There's lots of data that goes on. All right, so at first blush, I think IaaS actually checks a lot of these boxes, right? When you start thinking about, well, it's got an API, it's got a lot of introspection, it's got a lot of things. Well, let's just, we can build everything on top of IaaS. But it turns out there's lots of things that IaaS hides, right? IaaS fundamentally is x86 as a service. There's lots of things that we do via SSH or using top to figure out what processes are running that just are not in that API, right? And moreover, a virtual machine is not an application, right? There is not a one-to-one, generally speaking, between a virtual machine and an application. And really what we care about and what we want to be introspecting and what we make statements about are applications, right? So we need our APIs to be application-oriented rather than being machine-oriented. And that's really why I think that container management and containers in the form of, and I want you to know the rocket, it was in there before you gave the talk, right? I didn't edit that in right at the last minute. Not saying I've ever done that. The combination of container management systems as well as container runtime systems and container images in particular mean that we really have a chance of achieving a lot of those goals. So all of those requirements that we had for our introspection and audit and insight, these systems now provide those tools and do so in a way that I don't think has ever really existed before. All right, so how do we do this? Why is this the right thing? Well, containers are just the right API object, right? They are application oriented in a way that the virtual machine never was, right? And they should be immutable. I think at this point we all sort of understand that when you deploy a container, it really should be immutable, and you can also do things that make sure that it's immutable, right? We can ensure that we have checksums in all of our images, and we can run through those checksums, and we can make sure that the current state of the world matches the checksum. We can even mount parts of the image read-only if that's what we want to do. And then they can be verifiable as well, and we'll talk a little bit more about what that means in terms of, and Rocket had some of this, but in terms of tracking the container that you're running all the way back to a particular commit in a particular source tree, right? So containers can be verifiable. And then cluster management, in particular in this case in Kubernetes, provides a lot of the other stuff, right? So the container provides a lot of the low-level pieces. The cluster manager really provides the API in terms of organization, labels that we're all familiar with, the introspection of being able to use label selectors to slice our way through different parts of the system. It has the declarative specification of what I want to be running. It has the status of what is actually running. The API has been split into specification and status. And then finally, we have a pretty rich event stream that tells you when things happen, when a health check failed, when a container was restarted, when a container was created, all of this kind of stuff. So I think the combination of these two things together really provide a pretty robust system for doing insight, audit, and providing insight, doing audit, and doing introspection. Right. However, I don't think it's sufficient, right? When you look at Kubernetes, we designed it very purposely to be a very decoupled system, right? We really wanted everything we didn't want a hierarchy of objects. We didn't want replication controllers to own pods, everything grouped together by these dynamic label queries. But it turns out this is actually a really bad system if what you want is insight, right? It's a really bad system if what you want to be able to do is find out the relationship between traffic on an IP address going to a particular service that is related to a bunch of pods. You really want there actually to be fairly tight coupling. It's just, you want there to be tight coupling in the context of the query that you're executing rather than in the system that you're building, right? So we're stuck with this problem of, well, how do we have tight coupling when we're going and doing queries and tight relational stuff when we're doing queries and yet have a system that was, and an API that was really not architected for that. And so in order to do this, that's what I just said. In order to do this, I've been prototyping and developing a system that I've been calling KSQL. And it's out there on GitHub now, so I'm playing around with it if you want to check it out. And basically what it is it's taking the Kubernetes API and it's mirroring it into a relational database. Right? There's a couple different reasons for this. One is because now I'm establishing the relationships that allow us to do queries, but also, frankly, why reinvent the wheel in terms of expressions and how you would go about executing these kinds of queries, right? We have SQL, it works pretty well. Lots and lots of people are familiar with it. Someone once said to me that it clearly placed me as coming in the age in the software industry in sort of the mid-90s that I knew SQL. But, it works. And so, interestingly enough, many CTOs fall under that category as well, so it makes it easier to sell it to them. But this is the ability now to actually have a dynamic perspective onto your API that allows you to answer a lot of these kinds of questions. And I wanted to walk through examples of how this works. All right, so for example, you can say things like, who's running MySQL, right? I can say, select count from containers where container images like MySQL. This gives me the number of containers out there that are running MySQL. Right? I can say, give me group. Again, this is one of the reasons why SQL is valuable, because suddenly I have all of this ability to do things like group by, right? I can say, give me the number and the image. This is where I wish I had the demo. But the second query here tells you how many different versions of MySQL am I running, right? Suddenly now I have some insight into, holy, whatever, my developers are running 10 different versions of MySQL. This seems like a really bad thing, right? If we want to build up shared state and shared knowledge, and understand if we're vulnerable to various security problems, we really want to be running one, maybe two versions of MySQL. Suddenly, using the container API and the container image and this interface, I can answer those questions very quickly and very easily. But I can move on from there, right? And I can actually say, well, actually, who's running an old MySQL? I'd like to send them email, right? And so,
If you want, I can try to connect.
well, maybe at the very end I can get to the demo. Thanks, though. So I can say something like, actually, I want to select this specific annotation, the email annotation and the image, where the image is like MySQL 5.5, right? And I can go out and I can say like, well, actually, I'd rather you were running MySQL 5.5. I'm not a MySQL expert, so I don't know which version you actually should be running. I can send email to these people. I can send this into a mail merge now, and I can actually say, hey, you're running an old version of MySQL. Have you considered upgrading? Here's the document that describes how you should upgrade. Okay, this is beginning to actually show us where we can actually go with these things. But of course, when you actually execute this query, what you find out is that half of the people out there haven't actually bothered to put the email on their pod in the first place. So, right, you don't actually get to email them. And so that comes down to the fact, like we say this, which is, let's select the name of the pods from the list of the containers where the image is like MySQL and there's no email, right? Now we actually have a list of containers where somebody violated this policy, and if we're feeling particularly draconian, we just kill those containers, right? And that's where the sort of like audit and verification comes in. Or we go out and maybe by looking at the name, we can figure out what the team is, and we send a nice harassing email to that team and says like, hey, maybe you want to do this. And then we'll see a little bit in the next part, in the audit part, about how we can actually use some features of Kubernetes to actually make sure that these kinds of things actually don't happen. All right. So that sort of covered introspection and this idea that we can use SQL and SQL syntax while still having the data in the Kubernetes API. I should say that I'm not actually, it's an in-memory database, right? It's not actually sort of mirroring the Kubernetes API into an actual SQL, well, it is an actual SQL database, but it's not a very persistent SQL database. It's more of a transformation of the API into a structure that makes querying easy. All right, audit. So there's a real value to code review. I think we all agree on this. I think this is something that is non-controversial now. It's taken a while, but it's now non-controversial for all of the reasons I said earlier. But how do you actually make that happen, right? Well, there's a bunch of different things that you need to be able to do. The first is, and that Kubernetes provides, the first is that you need to lock down all those machines, right? Your developers should not be able to SSH into those machines. That's the first step, right? Because if they can SSH into the machines, all bets are off. They can basically do whatever they want. Everything comes in. But with Kubernetes, you can do this, and everything comes in through the Kubernetes API. Even exec, even the things that can give you a shell, that can give you the logs, all of those things can be done via the API, and because they can be done via the API, we can actually do things and enforce that the containers actually stay immutable. We can turn off exec, for example, if we really want to, and make sure that you can't go into a container and run apt get foo. Right? And then we need to do this for images as well, right? So we have version control at the far left. That's where the sort of source of truth is. We're going to have build automation, that is the thing that's actually responsible for producing a container image. We're going to have restricted access to our container registry, right? Average users should not be able to push images into their container registry. If they can do that, well, they can do whatever they want, right? You only want your build automation to be able to push containers into your registry. Because then you know for sure, because the build automation is only pointed at version control, that every single image that gets pushed into your registry came out of version control, came out of something where you actually checked that code in. You push it into a private container registry, GCR, or any of your others, and at this point now, we have a good guarantee, and you label, by the way, you label that image, its version with the Git hash, because now we have a very good, strong belief that the image that we see is verifiable back to a specific commit in version control. Okay? And that gets us halfway there, right? Now we have relatively trusted images. But then we also need to do the other side, which is how do I actually ensure that the user only pulls images from that registry? And this is where we get into things that happen in the API server. So I want to take a brief minute. CJ's in the audience, and he's like the expert on this stuff, so I'm probably going to totally hash it up. But if you're interested in details of authentication, and specifically details of authentication as it relates to Google IAM that is rolling out, CJ is the expert. A lot of this stuff is going out in 1.3, and it was going to allow for much finer grained control of who can do what on a Kubernetes cluster. Concretely, what happens is when you're going to do authentication, you walk up, and I stole these slides from him too, actually. I edited them slightly, but I mostly stole them. So if they're terrible, it's his fault. If they're awesome, it's my edits. So when you create a pod, you come in with this bearer token, and it goes through a bunch of these pluggable authenticators. Bearer token, it has basic HTTP basic auth, it has a client certificate, and then we have a bunch of plugins, and it says, are you authenticated? And if you authenticate, then you have an identity, right? So authentication takes care of establishing your identity. Then you move on from authentication, and you move to authorization, right? And so once you're authenticated, you present an authorization, and you can do access. I never remember what is ABAC access. No, attribute-based access control. Or you can go through a plugin, and that's where a system like Google's IAM system or Amazon's IAM system, any of the existing cloud IAM systems, or other, there's, I think OpenStack has Keystore, something like that. Any other kind of authentication system can be plugged in there. Active Directory is another one that is very popular, as I hear. And that is what provides you with the notion of like, well, okay, I know who I am. Well, now am I approved to take a particular action? Am I someone who can do an exec? Am I someone who can create a pod? Am I only someone who can maybe list pods and introspect them? And this basically makes sure that only people who you trust are the people who are actually, doing things that may be changing your cluster, for example. Lots of people can read, very few people can write. It's a very powerful thing. And in particular in GKE, there is a binding to Google accounts, right? So you can actually have the ability to set these policies based on specific Google accounts, and that will enable people to have those, establish the different privileges for your team. But that's only part of it, which is the other part that you want to be able to do. So you can, sorry, go back to that. By doing this, you can actually prevent people from creating pods, for example. You can say, those people, all my developers, they're not allowed to create pods. Only my ops people are allowed to create pods. But then you want to take it a step further, and you want to actually be able to say, well, actually, I want to be able to restrict the kinds of pods that people can create, right? Because there's nothing in the authorization or in the authentication or authorization that deals with what type of thing are you creating, or excuse me, beyond the resource, the specifics of the resource. It doesn't actually dive into the object and actually look at what's going on. And so the thing that actually does that, or the place where you can do this kind of thing, is this notion of admissions control. So inside of Kubernetes, there's pluggable admissions controllers. There's a variety of them already. And this is the place where I can actually say, well, if I go to GCR, if my image is GCR my company front end, admission control policy says, yep, you're good. I'll let that in, right? But if, someone says, hey, it's just my image registry, or it's my image from here, the admission control policy is going to say, no, right? We're not even going to let that image into the system, right? And that's how we can take those images that we've gone from version control all the way into the image registry and establish trust there. And then we can say, well, we know for sure that we're only pulling images from this specific registry, this specific front end, or excuse me, this specific sub-registry within the registry. We know that those came out of our version control system through our build automation. We know that those are images that we can trust. Right? And then finally, you can do the other side of audit, which is validation, right? So you can actually go back to something like KSQL and you can actually say, well, I want to select from and find any containers where the name is not GCR, and I'm going to pipe that to kubectl delete, right? And so admission control really shouldn't let these pods exist, but if somehow, some way it gets in there, this is the place where you can come back through and delete everything else as well. So the idea of the introspection and the explicit blocking in the front can work together to actually give you a really fairly strong assurance that only the images that you think should be running are in fact running. All right. You can do other things with admissions control. For example, you could say something like, if you request more than 1 core or more than 4 gigs of RAM, you need to have an annotation that indicates the ticket where you went to somebody and explained why your container needed more than 1 core or 4 gigs of RAM. You could say, you know what, if you're marking a replicated service as production or giving it an external load balancer, it's got to have at least 3 replicas, right? Every service that is created better be, you know, if you're calling it production, it better be replicated, right? You can have these, you can express these kinds of policies. They're not really about anything else like that, but they're about making sure that best practices are followed by everybody who's, you know, maneuvering through your cluster. It's a very powerful place to be. And because it's pluggable, it's very extensible. All right, and then lastly, you can say that the container API actually becomes a really powerful place for you to lay on even more valuable services. For example, there's lots of XSS scanners out there, right? You can have an annotation on your service that says, hey, this is a web service with these paths. I want you to go and explore it with an XSS vulnerability scanner, right? That means that just by deploying my application into my cluster, I'm going to get scanning for free. Right? Without even thinking about it, without even necessarily knowing that it's happening until the email shows up in my inbox telling me that it's vulnerable. Suddenly there is this sort of ability to create what Joe calls sort of the dial tone, right? The basic set of services that we live in become significantly more powerful than they would have if you were running on virtual machines or anything else like that. Where you'd have to use port scanning or another, you know, a variety of different techniques to actually figure out what was going on. Here we could just use the Kubernetes API. All right, and then finally I want to talk a little bit about insight, give some examples of the queries. You can say things like, what application hasn't been updated recently, right? We can sort all of, we can use order by, another SQL primitive, order all of our pods by their creation timestamp. And we can look for things that haven't been updated in 3 months. Inside of Google, there's this thing that's called Mosquito. And what Mosquito does is it runs around Borg and it looks for things that haven't changed in 3 months. I think it's 3 months. It might be slightly shorter. And if it finds those things, it sends you an email. And it says, hey, you know, we kind of pride ourselves on agility and, you know, code push. And you haven't pushed any new code in 3 months. And so we think there's a very high probability that this is some dead experiment that you ran. And you should probably go clean up those resources. Right? Because one of the flip sides of making it really easy to create containers is people create lots of containers and then they forget about them. And Borg just kind of keeps happily keeping them alive every time they crash or out of a ring or whatever it is. It just keeps restarting them, right? And that actually takes up a bunch of resources. And so there's this automated system that just rolls through and sends email every month, and people go and clean them up. You can say things like, which is the image that restarts the most? I mentioned this earlier, right? We can sum the number of restarts for a particular container, group it by images, order it by the number of restarts. Now you have a way of saying, like, oh, now I actually maybe understand what is the process. Maybe it's never been so bad that it caused it to page, but now I suddenly understand the process that is getting killed the most often. And maybe I should go and take a look at what the errors are that are causing it to be killed. You know, or what is the image from my service? Because I don't actually care if your service is crashing. I only really care if my service is crashing. I can do various groupings using all of the labels and things like that. Right, and then finally you can actually flip it around a little bit and actually say, well, maybe I'm a hardware ops guy. I actually don't care at all about what containers restart the most. I actually want to know what machine has containers that restarts the most, right? Regardless of which containers get placed onto it, there's a machine out there that's a little bit sick and things crash there more often, right? And so this is another kind of insight that you can obtain about your cluster, which says like, that thing, maybe that thing has bad RAM. And we need to go and take a look. We haven't picked it up on any other metrics, but the fact that more containers restart on that machine, dramatically more containers restart on that machine than restart on any other machine means maybe we should go and take a look at that machine. All right. So I think that the notion of having a container cluster, having an API like the Kubernetes API really means that we have significantly richer powers of introspection, audit, and insight than we've ever had before. I think it really, you know, the net of it is not that it's great to go through and audit things, but at the end of the day, these are the tools that enable us to make sure that you build scalable, reliable infrastructure health checking and all of the stuff that Kubernetes does to keep your service running is great, but also ensuring that the service that you build follows best practices is a very important part of that as well. And that's about it. Thank you very much. Thanks for the loan of the laptop. I did promise a while ago that I was going to bring in my Raspberry Pi cluster, and it's in the back. It's plugged in. You can't see it, but it's back there. So if anybody wants to check it out afterwards, or anybody wants to just chat, I'll be around. And that's it. Oh, questions, right? I'm supposed to ask questions. Anybody have any questions? Yeah.
Okay, so that was really quick, but you have role-based access, right? You have the different, say for example, I wanted to have a scenario where I have a development cluster, right?
Right.
A quality cluster for pre-production testing, etc., and then the production testing, right? Can I do write my own test and just run it on the test cluster and not on the production one, and have only testers be able to have access to this, while only developers have access to this?
Sure. Yeah. So I mean, I can do even better in the sense that you can actually run one cluster, and you can use namespaces as your access control domain, right? So you can actually say like, only this class of user gets to access resources in this namespace. Only this class of user gets to access resources in this namespace. Things like that.
Okay.
So if that's, I mean, it kind of depends on your security model, right?
Yeah.
Because those containers will co-locate.
Right.
So if that matters to you, then you maybe don't want to do that.
Right.
But so you can do both of those things, I guess. We don't try and represent identity or access control groups.
Mm-hmm.
We merely interface to systems that do. That's not entirely true. The ABAC thing is actually file-based, so that's not entirely true. But there's a few, I guess, we do have some local identity, but in general, the model that we want to have is that we access identity systems, we don't implement identity.
Okay. Yeah, at some point you also said that the database exists in memory.
Yeah.
Okay. Is there then a maximum size of cluster?
Probably. Haven't hit it, but probably, yeah. I mean, there's no reason you couldn't put it in MySQL, but it feels a little heavy to do it, right? Yeah.
So the fact that you've got some sort of database of state of a cluster means you could do more things. You could do interesting things. You could do replication. You could imagine, since you're now keeping state in a certain way, that you could imagine you could have replicated Kubernetes clusters that would use the things that we all know and love from databases to do replication.
Sure.
So I'm just wondering, like, have you thought of what else you can do as you start to sort of tee your API as it comes into your cluster? Off to the real cluster to do stuff, off to keep the stuff in storage with state, and then what else?
Yeah, I mean, I think one of the first things that I want to try is actually there's a ton of really rich visualization tools out there.
Yeah, sure.
I sort of mentioned visualization, but I didn't really talk about it. And one of the other reasons to choose SQL is that there's plenty of tools out there that they know how to visualize SQL. And I think that'd be a great first thing.
So you're saying it's only read-only, and only you select something right now?
That's right, yeah, it's only read-only. And I don't think, I'm not planning on ever changing that. I mean, I guess we can talk about it, but like, that seems messy. Yeah, it's really intended as an introspection tool, not as a management tool.
That point, so I'll just add the index of stat.td and build the SQL interface stat.td itself.
Yeah, so something along those lines, right? Yeah, I think that the idea is really more to say like REST by itself is not very relational. And we want to have a REST API. We want the API to be RESTful. But when you're doing a lot of this kind of introspection, actually it turns out the ability to express those relationships is actually really valuable. Anything else? Cool. Well, thanks for turning out. Thanks for sticking around. Thanks to Matt.
And a couple of host announcements real quick. There's a ton of pizza back there, including boxes that haven't even been opened. So please go and take an entire box of pizza. Take it home, feed your family and rabbits, friends, and everything else. So please take pizza. There's also some swag back there. There's a little bit of Kubernetes swag, more Google Cloud swag, and 2 Go Furs. So